All right, this time we've got our last assignment, which is limits using conjugates. Now this definitely relates to the limits by factoring question you saw before. The idea here is, trust me, if you plug in 3 by direct substitution, you will end up getting 0 over 0. And that is what we call indeterminate form. It means you can't say anything yet. You need to do algebra and then figure out a way to evaluate this limit. So what is the algebra we need to do here? Well, you can see this as limits by conjugates, and conjugate is really just a fancy term for an algebraic expression where the sign in between two things is switched. So what conjugate do I care about here? Because usually with conjugates we care about the denominator, but in this case the conjugate we care about algebraically is the conjugate based on the term or the part of the fraction that has the square root in it. So this numerator has square root of 2x minus 5 minus 1. So the first part of the numerator is this whole square root. The second part is the 1. They're separated by a minus. And we're going to multiply both parts by the conjugate of that term, which is 2x minus 5 plus 1. We're switching the sign in between. That's what a conjugate does. And 2x minus 5 plus 1. And I'm going to FOIL this out underneath. So I'm first going to deal with the numerator, but again, I got to stop here and just say one more time for emphasis. The reason we're doing all this, trust me, do it for yourself, try it. If you plug 3 into the numerator and 3 into the denominator, this will read 0 over 0. That's why we're doing all this work, because 0 over 0 is a nonsense answer. If it was just 0 in the numerator, we'd have 0. If it was just 0 in the denominator, it'd be does not exist. But since it's 0 over 0, we have to do some nifty algebra to find our correct answer. So again, I'm using the conjugate. The conjugate's based on the term with the root, so the numerator has the root, so that's where I'm getting my conjugate from. Let's FOIL the numerator. So when I do 2x minus 5 times 2x minus 5 in the roots just cancel, and I get 2x minus 5. Up next, you would have a positive 1 root 2x minus 5, then you have a negative 1 root 2x minus 5. Those two will cancel each other out. You have a positive of something and a negative of something, that's 0. All right, if I have positive $5 and negative $5, I have $0. So same idea here. Since you have a positive of a root and a negative of a root, you have none of that root left over. Last but not least, negative 1 times 1 is just negative 1. Okay, in the denominator, here's just the trick to this question. Never distribute the denominator. Write it out as each one separately. Or not necessarily the fact that it's the denominator, but never distribute the two things that aren't alike. So in other words, I distributed the conjugates and did all this FOILing, but the two that didn't match, those are the ones I write in parentheses. And maybe you can see why, because let's look at our next step. I'm going to clean up my numerator. That's 2x minus 6. And I'm going to write it like this over that whole denominator. And now I'm going to look at my numerator again and say, wait a minute, both of these have a 2 in common. Let me factor that out. And now, over the same denominator as before, but this time I'll write it out. So hopefully you can see why I just wanted to skip over that. I'm just trying to show clearly what I was doing to the numerator without writing the whole denominator over again. Okay, so here we are now. And this is where the special part of the problem comes in. Now, x minus 3 over x minus 3 totally cancel out. Awesome. So maybe you can see why I decided to leave these non-conjugate pairs undistributed. That's going to happen every time in your problem. Okay, so here's what we have now. Let's bring the limit back to this. We're trying to take the limit as x approaches 3 of, let's see what we're left with, 2 over root 2x minus 5 plus 1. Okay, and so I'll just stop and pause and say one thing here. Again, I'm not following totally correct algebra. Technically, I should be writing the limit notation every time as I do the algebra. If you're planning on taking calculus, you should plan on writing the limit after every single time. Otherwise, it's technically not precise, but I'm not really concerned about that right now amidst everything going on. So now when I plug in 3 to take my limit, I get 2 over, plug in 3, this is 6 minus 5, which is the root of 1, plus 1. So now I have 2 over 1 plus 1, that's 2 over 2, so the limit is 1. So again, I go from something totally impossible to something solvable. Okay, now we've covered a lot of the groundwork, so hopefully we can get through our next example a little more quickly. Again, trust me, try plugging in -4 into this. You'll end up getting 0 over 0. So this time, we have our x plus 4 over this whole crazy mess. I'm waiting to see one particular example, but I haven't seen it yet. Now this time, again, what I said before is true. The conjugate should be based on the terms that's the square root. So this time our conjugate is going to be the root of 3x plus 13 plus 1. So I'm taking the term that has the square root, either the numerator or denominator, and I'm switching the sign. And let's also just remember that the reason that we're multiplying the numerator and denominator by the same thing is because technically, if you have something over itself, this is just 1. So we're just multiplying this thing by 1, which means we're not changing its value, we're just changing how it looks. Okay, my advice from before is leave the non-conjugate terms undistributed. So I'm going to write it like this. And I'm going to quickly FOIL out the denominator here. Again, when you FOIL out the root times the root will cancel out and you'll just be left with the contents. You'll have a positive 1 of that root and a negative 1 of that root, so you'll have none of those roots, they'll cancel out. And then again, you'll have a minus 1. All right, this time I'm going to go a little bit quicker. Hopefully you see that this is 3x plus 12, and hopefully you would agree that you could factor out a 3 from that. So now I have x plus 4 times root 3x plus 13 plus 1 divided by 3 factored out of x plus 4. Our x plus 4's cancel, so finally we're taking the limit of x approaching -4 of the root 3x plus 13 plus 1 all over just 3. When you plug in -4 here, this is -12, so -12 plus 13 is 1. The root of 1 is 1. 1 plus 1 is 2, so we get 2/3. And got time, and we've got one left over. I'm waiting for one last thing to happen here, and this is it. Okay, same idea as before. I'm going to go a little bit quicker. We have 2 minus the root of 4x minus 12 all over x minus 4. Again, trust me, you would get 0 over 0. The conjugate is going to be 2 plus 4x minus 12. Again, the conjugate's based on the part of the fraction that has the square root in it. Now this time, our example is different, and it's going to be more important that you know your algebra skills, because this time, the square root is on the second half of the fraction. So this is going to be really important. When we FOIL the numerator, or when we FOIL the conjugate pairs, 2 times 2 is 4. And from there, you'll have a positive 2 of that root. You'll have -2 of that root. Again, those will cancel out. Now this time, you will have positive of that root times negative of that root times positive of that root. Now positive times a negative is a negative, and this time the roots will cancel out. Be super careful. When the roots cancel out, you will have parentheses, 4x minus 12. That negative out front from the plus minus is going to distribute to both parts of the inside contents of the root. This is happening because the root is written second. Technically, you should be writing it in parentheses every time, but when it leads, it doesn't really behave the same. So this is the important thing to notice about this problem. Again, all of this is over. Don't distribute the non-conjugate pairs. X minus 4 times 2 plus the root of 4x minus 12. Okay, now from there, again, hopefully you would see that this is now -4x plus 12 from a double negative. So we have -4x plus 12, and there's also a 4. So this is really -4x plus 16 when you distribute that all out. Okay, so now, again, I'm going to look at that cleaned up numerator and say, wait a minute, I can factor out a -4. When I factor out the -4, I'll have x minus 4 inside over x minus 4 times that whole ugly root thing. X minus 4's cancel. Now I can take the limit as x approaches 4 of -4 over 2 plus the root of 4x minus 12. And this time when you plug in 4, you get 16 minus 12. 16 minus 12 is 4, and so we have negative 4 over 2 plus the root of 4, and 2 plus the root of 4 is 2 plus 2, so this whole thing is just negative 1. Alright, best of luck. Hopefully these videos helped. If you have any questions, again, make sure you reach out to me.